Alright, y'all, so here we're going to cover 6.3. So there's a few things that I want to mention before we get started. First, after every lecture recording that you watch, you need to make sure that if you have developed questions about the content that was covered, that you go to the discussion board that is related to that section and you type in or upload, take screenshots, whatever you need, those questions and concerns into that discussion board. I am going to be using those discussion boards in order to help facilitate our virtual classroom time periods, so it will be a big help if you have questions to put them there. If you don't feel like putting them there for all to see, you can always wait until our virtual classroom meeting time, which is once a week on Wednesdays, and I'll be happy to answer anything that you have, as well as you can email me should needs arise. So this is going to be your lecture over 6.3 volume, okay, as if we were face-to-face. So we've already talked about the 2D space using area and perimeter. Well, 3D space or volume adds that third dimension to your objects. Okay, so instead of talking about a square, now we're talking about something like a rectangular solid or a cube. Well, with those, and just like with the originals, we had all these formulas that we had to know. Well, we've got the same thing here. So we've got a whole list of formulas that you have to be aware of. Okay, because in the formula sheet for your exams, remember your formulas are not labeled, yet they are there. So when we're talking about a rectangular solid, we are talking about V equals length times width times height. Okay. A cylinder uses the formula V equals pi times the radius squared height, where pi is going to be 3.14. Okay, now we've already kind of talked about that a little bit, but it's going to be the same here. So when we're talking about pi, we're talking about 3.14, not necessarily using the pi button on your calculator itself. Now a sphere, volume equals 4/3 pi r cubed. Okay, again, pi is 3.14. When we're talking about a cone, volume for a cone is going to be 1/3 pi r squared height. So it's almost like your sphere, except for we're adding this height component to it. Okay. Now your rectangular prism is going to be 1/3 length times width times height. And last but not least, we have your regular prism, which is going to be volume is 1/2 base times height times length. Now we also sometimes refer to this one as your triangular prism. So be aware when we're talking about things, these are the different formulas that we have to be able to use. Well, if you had printed these notes out, which I highly suggest that you print the blank copies and you take notes along with the recording, you would notice that the next couple of pages are purely shapes. So what I wanted to do is kind of give you essentially in this course an example of the different shapes that we're going to be using. So we've got our cylinder and our cube, we've got our sphere and our cone. Some of the ones that are not as familiar are going to be your rectangular prism. Now it's a rectangular prism because it's got your rectangular or your type of bottom, and the pyramid part is because it comes up to a point. And so here it's coming straight up to this point here, and that's where the pyramid comes from. Your prism, or specifically in this case, your triangular prism, is done in this shape. And of course, with all of them, you can see where the different variable components of the different shapes lie, so that when you are working your problems, you know which part of the shapes belong to which part of the formula. So, getting into the specifics, you're going to see some examples where they ask you to find the volume of each figure, and it's asked you to round to the nearest tenth. Now notice, I don't tell you which type of figure you have. You have to recognize the shape. Here, however, I'm telling you that height is 5.2 and the radius is 1.9. So this is a cone. So the first thing you need to do is you need to recognize the shape that you have. And in doing so, that is going to allow you to remember your volume equation, which for a cone is 1/3 pi r squared height. What you simply need to do is plug in the information you have. So this is going to be 1/3 pi times your radius, which is 1.9 squared, times your height of 5.2. And what you need to remember here is, of course, you need to recall that pi is 3.14. And when you do that, you should come out with getting a volume of 19.6. My units were in feet, so this is feet cubed. Now, units are important. Yes, you will lose points if you do not have proper units on your problems. Okay? Again, please double check my math behind me to make sure that I haven't made any errors. Let's look at another one. Here I'm telling you that the height is 38 inches and the diameter is 21 inches. So when we look at this picture, again, you have to be able to tell me what the picture is. And in this case, we're talking about a cylinder. And specifically, you have to know what the information is that a cylinder has. Well, we know the height. We also know if you go from the center out, this is the radius. Well, we also know if you go from point to point, that is diameter. So you have to remember here that diameter equals twice the radius. Well, in this case, I'm told that the diameter is 21 inches. So here I have 21 is equal to twice the radius. So 21 over 2 is equal to my radius. Now, you can actually do that in your calculator and spit out an answer and use the decimal, or you can use the fraction while you're working and still get the same result. Okay, so whether you use 21 over 2 or you use 10.5, you're going to get the same answer either way, or at least you should. So for a cylinder, my volume is going to be pi r squared height. Okay? So here again, we have to plug in the information we know. Pi is 3.14. My radius was 10.5 squared. And then my height is 38 inches. So when we multiply all of that together, you should come out with 13,155.03, and then this is inches cubed. Okay, let's work another one. So here we're told that the length is 25 meters, the height is 9 meters, and the base is 8 meters. So we have to be able to figure out where each of these go. Well, remember, this is my length. Okay. This part right here is my height, and this part right here is my base. So if we're looking at what we have, my length is 25 meters, so this was 25. My height was 9, so this is 9, and my base was 8. Well, we also need to know what this is, and this right here is going to be our prism. So if you remember your prism, volume equals 1/2 base times height times length. So we simply need to plug our stuff in. So this is 1/2 times my base of 8 times my height of 9 times my length of 25. And when we do that, you should come out with 900. My units here were meters, and I had 3 of them, meters cubed. Alright, so now we have a capsule in the shape of a spear that has a diameter of 3.7 millimeters. So again, remember, diameter equals twice the radius. So in this case, I have 3.7 equals twice the radius. So 3.7 over 2 equals my radius. And if you go ahead and do that, you come out with your radius being 1.85. I would use that decimal as a whole, and I would go ahead and round at the end. So my volume here is going to be 4/3 pi r cubed. So again, this is going to be 4/3 times that 3.14 times the 1.85 cubed. And when you do that, you should come out with 26.5. Millimeters is a double M, and I had 3 of them, so it's cubed. Okay. Alright, let's do another. Here I'm told the height is 26 feet, the length is 22 feet, and the width is 19 feet. In this image, your height, width, and length have all been labeled. So we know my height was 26, we know my length was 22, and my width is 19. This right here is a rectangular pyramid. So when we're looking at that, we need to remember volume here is going to be 1/3 length, width, height. So here we've got 1/3, and we're going to have 22 times your width of 19 times your height of 26. So this is going to give you 3622.7, and then this was in feet, so feet cubed. Okay. So now we've got your height is 44, your length is 9, and your width is 5. Okay. So again, my height is 44, my length was 9, my width was 5, and this would be your cube or your rectangular solid. And so in this case, your volume is going to be length times width times height. So here you're going to have 9 times your 5 times your 44, which gives you 1980 feet cubed. Alright, enough of the easy ones. This next example takes 2 shapes and puts them on top of each other. So we're told that the diameter is 8 meters, the height is 10 meters, and the cone height is 4 meters. So you need to be very, very careful as to what that means. First and foremost, this is your height, and this right here is going to be your cone height. So I'm telling you the overall height here is going to be 10, but your cone height is 4. Now the other thing that we tell you is we tell you diameter. So here remember, diameter equals twice the radius. So 8 equals twice the radius. So 4 equals my radius. So this piece right here is your radius, which is 4. So now we're going to have to find the volume of your cone and add it to the volume of the cylinder to get the volume of the total. So we have to run them separately. So first we have to look at, say, the volume of your cylinder, which is going to be pi r squared times the height. So again, this is going to be 3.14 times our radius was 4, so times 4 squared, times your height. Now we're talking about the height of the cylinder, so in this case it's 10. And when we do that, you should come out with 502.4, and remember this was meters cubed. Now we need to find the volume of the cone, which is going to be 1/3 pi r squared height. Plug in what you know, so this is 1/3 times 3.14 times that radius of 4 times your height. Now this time we're doing the height of the cone, so times 4. When we run that through our calculations, you should come out with 67 meters cubed. Therefore, the volume of your total has to be the volume of your cylinder plus the volume of your cone. So in this case, we have 502.4 plus 67 gives us a total of 569.4 meters cubed. Now what happens if we don't actually have the shape? Well, you could draw it if you need it, but first let's read the problem. It says the concrete foundation of a house requires 15 truckloads of concrete. The concrete was poured at a depth of 0.5 meters and covers an area of 540 square meters. First, how many cubic meters of concrete were used? Well, what do we know? We know volume is going to be length times width times height. What do we also know? Well, we also know that area is length times width. So therefore, my volume equation is actually area times height. Well, in this case, my area is going to be 540 meters square. My height is going to be the same as depth. Okay, so you have to remember when we're talking about depth, that means height. Okay, it's just a different word. So here my depth was 0.5 meters. So this is going to give me a total volume of 270 meters cubed. Now the second part says if each truckload was the same size, how many cubic meters did each truck carry? So fairly simple. I need 270 meters cubed, and I got to divide that among the 15 trucks that I had, and that's going to give me how many meters, or the volume of each truck. And in this case, you end up with 18 meters cubed per truck. Okay. Alright, last one, and it's a multi-parter. So it says, a grain silo in the shape of a cylinder is 75 feet tall and has a diameter of 24 feet. First wants to know what the volume of the silo is. So remember, my volume here is for a cylinder. So this is pi r squared height. So this is going to be 3.14 times my radius. Now remember, my radius is going to be diameter divided by 2 times my height of 75 feet. Well, in this case, my diameter is 24. So this is 3.14 times 24 over 2 times my 75. So when we do that, we're going to get 33,912 feet cubed. Okay? Oops, I forgot to write in my squares. I thought something had looked a little funny. So as always, please make sure that you are double checking my math as we go to make sure that I haven't made any mistakes like that. So again, here, remember your little squares, whereas me, they just seem to drop off. Okay. The second part says, if a bushel of grain is 1.25 cubic feet, then how many bushels of grain will the silo hold? Well, in order to do that, we need to know the volume of the silo divided by the volume of your grain. Well, in this case, the volume of my silo is 33,912. The volume of 1 bushel of grain is 1.25. So my silo is actually going to hold 27,129.6 bushels. The last thing says, if a truck can unload 200 cubic feet of grain per minute into the silo, how long will it take to fill the silo? So, first thing that we need to know is we need to start with how many bushels fill it. So we have 27,129.6 bushels. Then we need to do some conversions. So this is where my science is going to come out of me, because I do my conversions as if I was converting moles, which obviously you don't need to know what a mole is, but it's going to look a little bit different than maybe what you are used to. So just bear with me and I'll show you exactly what's going on. So we are converting from bushels down into time. So we have to work with what we are given. Well, we know we have 27,129.6 bushels. We also know that we have 1.25 cubic feet per bushel because of the problem before. So when we are talking about getting rid of our bushels, we know that 1.25 cubic feet is the same as 1 bushel. And then we also know that we can unload 200 cubic feet of grain per minute. So when we're talking about our minutes, we can unload 200 cubic feet per minute. Well, the last thing that we know is that we have 60 minutes per hour. So if we want to know how long it is going to take, essentially what we're doing is we're multiplying. So in science, essentially it's the same as fractions. You would multiply across the top, and then you would divide by across the bottom. Well, when we do this, you can see that your units are going to cancel. So my bushels here go away, my feet cubes go away, my minutes go away, and it actually is going to leave me with doing 27,129.6 times 1.25 divided by 200 times 60. And when we do all of that, you should come out with 2.83 hours. Because notice, the only thing that's left is your hours unit. Okay? So that, in a nutshell, is everything that you need to know about section 6.3 as it relates to volume and the different volume problems that you may have. As always, if you have any questions or any confusion, please leave your notes and comments in the discussion board so that I can address them when we have our virtual classroom.